Okay, everybody good here? Okay, magnitude is the length of a vector. Okay, can represent speed, distance, or force. And we saw from before, magnitude as a formula, square root of a squared plus b squared. Okay, find the magnitude of vector v if vector v has component form of -3 and 8. Okay, find the magnitude of a vector with initial point A and terminal point B. And then also find the direction. So first, we're going to take our order pair. We're going to build our vector using x2 minus x1 and y2 minus y1. Once we get this into component form, like the first example, then we can use the numbers here to build our magnitude or to find our magnitude. Okay, x2 minus x1. Four minus -2, and then 5 minus 3. Sorry, 4 minus -2, so that's going to be 6, right? Okay, so once we have our vector in component form, we can find the magnitude, indicated using these vertical bars. And these are the only numbers that we need, right, to build our magnitudes. A squared plus b squared. Okay, you can use your calculator to reduce that or to clean that up a little bit more. 2 root 10. Okay, direction of the same vector. We can build that direction using tangents. Actually, sorry, this is meant to just be definition. We're gonna get to the example later. So direction is which way the vector is pointing to. In standard form. Okay, so we've been working with this already. Yes.
Where do you get the 4 minus?
Oh, sorry, that's not I. 4 minus a -2. That was just a stray mark there. I didn't mean to put that. Yeah, 4 minus -2, which is 6. Okay, and direction, we've been working with this from before. Now we're just putting it all together. Tangent of theta is equal to b over a. So we know that theta is inverse tangent of b over a. Okay, and we know that we have to make some adjustments, right? Second and third quadrant, you got to involve 180. Fourth quadrant, you got to subtract 360. All right, so now let's do an example involving directions. It says find the direction of vector 8, 5 8, 5, you can draw this out, or you can just look at those numbers and understand that this is first quadrant. This first quadrant, any reference angle you get is going to be your answer. There's not going to be any need to make any adjustments, right? This is quadrant 1. So whatever we get with our inverse tangent will be the angle that we can use. Okay, enter in your calculator, make sure you're in degree mode. Okay. Questions so far? Right, really not doing anything new, right? We're just going to be learning a few more new notations here. Next example, find the direction of vector that's in unit vector -6i minus 7j. If right now, I think for us, it feels more familiar when something is in component form. So I'm going to put this back in the component form here. Okay, so if you think about a vector that's -6, -7, which quadrant is that going to be in? Quadrant 3, right? So after we go through our inverse tangent, we have to make sure we involve 180. Okay. 49.39 degrees. But that's not quite what we need for third quadrant, so we need to make sure we add 180 to that reference angle. I did, yeah. Why is it? Okay, let's think about this scenario here. If the direction of vector x is 50 degrees, how would the direction change for each of the following? Okay, so 5x just means that it's going to extend the vector by 5, but it's not going to change any direction, so there's no direction change. Now, if I have a negative in front, a negative 3x, the magnitude is going to change, but it's basically going to be the exact opposite direction, right? So if something is moving is in 50 degrees here, then to find the opposite direction, we can either add or subtract 180. Okay, it'll continue along that line, but it'll just be pointing the other direction. 1/2 x, there's no sign change, so no direction change. Okay. yesterday, we kind of know how to do this already, but I just want to, there's a additional formula that can make it a little faster so that we don't have to go through as many steps. So yesterday we talked about how if we were given the vector and the direction, we can get this back into component form, right? So let's say this is vector v with a magnitude of a value, and if I want to get this in the component form, I can use sine and cosine, right? We discovered that yesterday when we were working with the task, the Harry Potter task. So if I want to solve for x, right, what would you use? Cosine, right? So yesterday we said cosine of theta is equal to x over whatever this value was. Right now I'm just going to leave it as magnitude of vector v. And if I want to solve for x, I would just cross multiply. Right? And if I want to solve for y, or if I want to solve for y, I would use sine, right? I would say sine of theta equals y over vector v, or the hypotenuse, magnitude of vector v. Cross multiply, and I would get y is equal to magnitude of vector v times sine theta. So the shortcut is that if I'm given a magnitude and a direction, I can just jump directly to this formula rather than building from scratch, even though it's fine to build from scratch. That way you're never having to memorize a formula. But because we can draw a triangle and fill this in, or if we see it enough times, we can just understand that, okay, if I have a magnitude and direction, I can just plug it directly into this formula. Because this represents my horizontal component, and my y is my vertical component. So I can go back and draw the triangle if I want, but then another option is just putting it directly into the formula that's building off of what we can conclude. So if we want to try it this way, magnitude is 5. That's the magnitude here. So 5 cosine of 25 would represent the x if I were to just draw the triangle. Okay. 5 sine theta okay, and then just enter in your calculator. So vector 4.532 will be the horizontal component, and vertical component will be 2.113. Now, we could do this the same way with the old method, and that'll be perfectly fine, right? You can draw a vector of 5, theta is 25, and then you would do x and y. You can go through cosine and sine, and you would get the same results. It's just that this is just another option. So we don't have to draw as many things if we understand that if we're given a hypotenuse and direction, you can plug directly into the formula rather than having to draw the triangle out every time. Okay, let's just work through a few problems on the next page. Okay, let's just do 2 from each section. Okay, does anybody still need this? So let's do 1 and 3. We'll do 39 and 41, and we'll do 45 and 47. Okay. Just the odds. Okay, find the magnitude. So let's get it into component form first, and then we can use our a and b values. X2 minus x1, y2 minus y1. Square root of a squared plus b squared. Okay, easy enough. Pythagorean theorem. Okay, order pairs. Let's get it into component form first. X2 minus x1 and y2 minus y1. 3 minus 10. -5 minus a -2. (49 plus 9, 58). Okay, we can finish the rest of the odds tomorrow. Let's go to number 39. Okay, find the component form with the given magnitude and direction. We can draw the triangle if we want, or we can start using this formula here. The x component is just going to be the magnitude times cosine theta, and then the vertical component is just the magnitude times sine theta. Okay, 4 cosine 135. Okay, these are unit circle values. So cosine of 135 is going to be √2/2. Sine of 135, sorry, negative √2/2. And sine of 135 is going to be positive √2/2. So that'll reduce to be 4 times negative √2/2 and 4 times positive √2/2. Okay, reduce the numerator denominator, I get -2√2 and a positive 2√2. Okay, 41. Magnitude and direction. You can draw a triangle if you want, get solve for x and y using sine and cosine, or plug it directly into our adaptive formula. Okay, cosine 330. This is in the fourth quadrant, so √3/2. Sine is negative in the fourth quadrant, -1/2. Okay, 45. Find the direction angle for each vector. So I personally like to put it into vector form, into standard component form. It just feels more natural there. But -2i plus 5j will be a vector that has component form -2, 5. Okay, which quadrant is that in? Yeah, second quadrant. So you know you got to involve 180 once you find your reference angle, right? Okay, you're looking for an angle measure between 90 and 180. This will do it for us. Okay, 47. Get that into component form, it just feels more natural. -4, -3. Okay, which quadrant? Third quadrant. Also, still need to involve 180. Third quadrant, we're looking for an angle measure between 180 and 270. This will do it. And 0.9. Any questions? Okay, we're not doing anything new tomorrow. We're just gonna have you guys finish the rest of this, the odds on page 13 and page 15. If you want to do it now, you can, but tomorrow can also basically be like a free day because we've already covered the material that we need for this week. Okay. Let me come around and just check off what you have finished for page 13 and 15.